Hey everyone, welcome back to the channel. Today's topic is JSON versus Toon. Okay, if you are building AI apps or working with large language models, then today's topic is going to blow your mind. For the decades, JSON file formats has been the default data format for the web, but with LLMs becoming the center of the modern softwares nowadays, JSON's uh, biggest weakness is suddenly a very big problems. But guys, guess what? There is a new kid in a town, and it's called Toon, Toon, token oriented object notions, and it might just change how we exchange structured data with AI system forever. So JSON versus Toons, the future of AI data exchange, where we are reducing 50% tokens as compared to JSON. So let's deep dive in the PPTs and subjects. So before going to the tunes, uh, just I want to discuss about uh, just brief introduction on the JSONs. Okay, so JSON is a lightweight text based formats that represents a structure data using key value pairs. Okay, means as a developer we loved JSONs. JSON is a amazing for the APIs like configuration files, software developments, and a database. Right. So we love it, right? In multiple projects we are using JSON in different style. So, but in the era of AI field, however, once you start using it inside the AI prompting, okay, the weakness of JSON become very obvious, right? Like JSON use braces, brackets, and double quotes everywhere. Okay, but in terms of LLMs, LLM tokenize punctuation individually, right? Means every repeated key added more tokens, right? Every quote marks, every bracket, every comma, every space, they are token in a LLM field, AI field. So everything is a token in LLMs, and token cost a money. Okay, so means the because of this, JSON produce almost 30 to 60% more tokens, and you are paying for every single one of them, right? So so first question, why JSON is inefficient for LLMs? See, actually if you are building AI application, right, you are probably burning through a tokens and a money. Okay, without even realizing it. Okay, when every tokens matters, if you are using 50% fewer tokens to represents the same data, can significantly cut expenses and processing time. Okay, so this is why, see, the first one is the syntax. Okay, so curly braces, quotes, comma, colon appears again and again in the JSONs. Okay, this is the first point. Second point is repetitions of keys in a big arrays. Every row repeats the same field. This is fine for the machine, but it is wasteful for LLM token uses. Okay. Third one, the token cost. um, LLM pay for every symbols, extra like extra punctuations and repeated key turns into real money. Okay, here token cost is a matter, right? So every tokens, every comma punctuation all are tokens. So here token cost is a matter in LLM. Okay, the fourth one is parsing overhead for the uh, over, parsing, right? Parsing that overhead for the models. Okay, so in simple terms, JSON looks very neat and clean to us, right? While you will see, it will very give the neat and really clear idea. Okay, so but however, to the model, it can be a very dense, busy forest of the symbols. Okay, so this can make um, reasoning harder. Okay, okay, so this represents the LLM treats JSON as a dense uh, symbolic noise. Okay, so token cost breakdown. Okay, here the problem when using JSONs with LLMs. Let's break down a typical JSON objects. So these are the JSON formats I have, that having the opening braces and closing braces, and these are the key that's contained under quotes and value that's contains under the quotes. Okay, so see here the curly braces, opening braces, one token, quotes another tokens, keys one tokens, colon comma space are 8 tokens. So even the closing braces one token. So see how many tokens are available in this JSON format. So this is one token, this is another token, key is another token, this closing quotes is another tokens, this colon is another tokens, this uh, quotes, double quotes, opening quotes another tokens, this value is another tokens, this closing quotes another tokens, this closing braces another tokens. So we have 9 tokens in this JSON formats, right? So this is, and LLMs don't want to use these curly braces and uh, these quotes and colon. Okay, because these are extra tokens are in the JSONs. Okay, so why JSONs are struggling in the AI area? Okay, actually in the uh, JSON is still perfect for the many things, like if you're doing the web development, so browsers loves it, the JSONs like request response. Okay, and backends also loved it. Okay, so but in large language model see JSON in a different way. Okay, but in terms of LLMs, LLMs pay token by tokens. Okay, JSON formatting turns expensive at a large scale. Add noises means very hard to reasoning for the models, right? So see, this is our JSON formats, and this is the opening braces user, ID, name, and role, the two records I have now. So see here the token count is 56 and character count is 102. This is the JSON formats. If you count the tokens, then you can count everything from here to here. You will get approximately 56. But in terms of tune, right? See here, users. This is the users here. Two records, ID, name, roles. One Alec admin, two Bob users. So see the tokens. Token counts here is only 22, and the character count is 46 here. Okay, so see, that's more, 50% token saved instantly. See here, it's here 56 and 22, so it's reduced almost 55% instantly. I'm We are saving by using these tools. So next is to meet tunes. Okay, so token oriented objects notions. um, it is a smart alternatives to the JSONs, and for AI applications that is built specifically for large language models. Okay, but why tunes matter for modern AI agents? Okay, so um, the rise of AI agent, uh, which brought a new bottleneck, the token efficiency. Okay, agent constantly exchange structured data with the LLMs, user profile, logs, tasks, tools, output, memory states, and many more places. Waste tokens makes the system slower and more expensive. So that's why Tune, these file formats is booming. So tool stands for token oriented object notions. Okay, it is a it is a next generation format for AI and LLM applications. Okay, and um, it aim to make a structured data efficiently. Okay, reducing cost of processing data within the large language models. Okay, so what is tool? Okay, so it is a compact, human readable, serializable formats. Okay, it is a compact, human readable serialization format, especially designed for parsing a structured data to the large language model with significantly reduced token uses. So, built specifically for LLMs and AI applications. Use significantly fewer tokens rather than JSONs, and designed for the parsing structured data efficiently. Okay, so it has some key features. Okay, and so tokens, so, okay, right, the token efficiency use 30 to 60% fewer tokens than formatted JSONs. Human readable, easier to read in logs and debugging than dense JSONs. Okay, and LLM friendly, um, uh, structure with array lengths declarations, field header and delimiter, um, scoping that improves LLM readability. Okay, and like it's a indentation based, borrows YAML indentation based structure for nested objects. Okay, so next thing is the tabular array uses CSVs, a tabular format for uniform data rows. So these are all the key features for the tune, right? Tune, tune file formats. So this is where tune helps. Okay, and next is what is the advantage? key advantage of the two toons here. So the first one is a minimal syntax. So toon strips out necessary characters. Okay, instead of braces and quotes, it used indentations and tabular formattings. So next is faster scanning. LLM reads tools like a spreadsheet. Rows and columns makes pattern easier to detect and reason about. Right. And third one is the more human friendly. Even the non-technical user can understand tools at a glance. Right. The fourth one is a cheaper to run, means if we have the fewer tokens, right, faster response, low API billings, and more effective memory uses. And fifth one is work perfectly for flat and tabular data. Not everything needs deep nestings. Okay, so most AI agents data that is simple and flat, which Toon handle extremely well, I mean in a optimized way. Right. So next is how Toon works. Toon data formats works. Okay. So Toon is built for a structured, consistent data. When every row, when every row uses the same fields, Toon Toon compress it in a clean AI optimized format that cost fewer tokens and processes faster. Okay, it combines the best multiple formats while optimizing for the token efficiency in LLM context. Okay, so see, these are the JSON formats we have. JSON formats, ID one, first name. So these are all the JSON format, and see the Toon format is ID one, first name, like that. So this opening braces, opening curly braces, quotes, it's removed. Okay, so I mean, see, if I'm here the same data, okay, same data from the JSON format and same data for Toon format. See that it reduces the token here. It is clear structured, right? So now why Toon matters for LLM's workload? Okay, Toon um, is a not just the shorter JSONs. It is a shape uh, around how LLMs works. Okay, so in modern model like LLM models, it's read read inputs as as a stream of tokens. Okay, so do best with the structure. It is clear and regular. Okay, and third one is struggling more when prompt are noisy or huge. Okay, so how the Toon helps here? So Toon helps in the different ways. So first one is fewer token than JSONs. Okay, so for large means if for fewer token, right, fewer tokens is equal to lower cost, right, we can consider. So for the large and uniform arrays of object, Toon um, often saves 30 to 60% tokens compared to JSONs. Okay, this can cut your LLM bill in half for the same jobs. Okay, fewer tokens. This is about the fewer tokens. Okay, second one is second the size. Okay, the size, because of you declare a key once and then a stream rows, the pattern become obvious. Okay, so model see a nice table instead of length forest of braces. so it reduce the sizes, right? So third one is readable and debugging friendly. Okay, so Toon keeps things readable. Okay, so you can open a Toon block and understand it in a single glance, which helps with the debugging AI API design and tests. So that is clear structure for earlier easier reasonings. Okay, so array size and the field list are explicited. This gives the model more hints and also makes it easier to validate the responses. Okay, so in short, the tools gives you the uh, a, a, a purpose built AI data format while um, staying close to JSONs. Okay, so when to use Toon? Okay, the next question is when to use Toon. So first one, uh, uh, we for the first one, flat tabulars and structured data uniforms arrays of objects with the same field across many rows. So user database where we can use product cataloging, log data, analytics, the data sets, and CSV like structures. Okay, second one, high volume LLM applications. So where the chatbots with the user context, AI powered search, recommendation systems, data analysis tools, AI frameworks. The third one, the cost optimization in is a priority. So startups with limited budgets where we can apply these formats, high frequency API calls, production applications at a large scales, context window optimization where we go and do our cost optimizations where the costing is the priority. The fourth one, prompt engineering scenario where the token count and context size matters like cost window limits etc. Okay, so large context windows, the first one. Second one, the multiple data source is in a prompts, fine tuning training data sets where I can utilize the prompt engineering and token efficiency. So here when we are using our Toon data types, 10 Toon file formats, and and when the Toon not to use, where the Toon we are not going to not use. Okay, the first one is deeply nested data. For deeply nested for non-uniform data, JSON may be more efficient, like you know complex object hierarchy, variable structured data. Okay, so there if it is there, right, the first we have to flatten it and then use the tone. Okay, and the second one is the standard API response. Tune a design is for LLM inputs and outputs, not as a general purpose data interchange formats. Okay, like REST API, graphs, GraphQL responses, client server communications, right? The third one is the database concepts. Okay, database concept mostly it's a primary data stores, relational database, document store, use case. Where is the use case? A store in the JSON and SQL formats, convert to tune for LLMs queries. Okay, and for non LLM processings, so where the client server JavaScript manipulation, when you are working with the JavaScript, so there you can required, not required, and traditional backend logics. Backend logic is not required, and in the data transformation is not required. Okay, and next is the semi-uniform data, like semi-uniform arrays. So here 40 to 60% tabular eligibility is there. So token saving diminishes here. Okay, so prefer JSON if you're using the your pipeline already rely on it. So guys, this okay. So guys, this is all about the tool, okay, which makes advantage over JSONs. And yeah, we'll do some practice over coding. Okay, so let's start.